So a lot of what you're going to be doing for this next section for 2 weeks is, again, review. We're combining things from like two different graphs, putting on one, talking about what happens when they intersect. So we can compare things not only with tables, but also with graphs, and talk about at the bottom, well, which one's a better deal. A lot of which we'll be doing today, tomorrow, is which one is a better deal. So here we got just two pricing plans. This is the actual pricing plan for the LA County Fair. So a good thing to start off with is labeling everything, so that when we're looking at this later, okay, we know this is the table for option 1. This is the table for option 2. And since we're going to have two lines or two graphs on here on our axes, we're probably going to label them there as well, so you know which is which. And as opposed to just saying X and Y here, put the actual variables. So identify the variables. We have a price, and we have how much is each ride. So we have to figure out that, you know, like our X variable is the number of rides. And our Y variable is cost. And that's the same for both. So these are small but important details. If we understand what it is we're trying to graph from the beginning, it makes it a lot easier to fill out the table. Same thing over here. If I know my X and Y from my table, I can fill that in here. I know that this should be cost, and this should be labeling your axis, number of rides. And we're not going to abbreviate it. We're not going to try to make it shorter so we don't have to write as much. We're going to put as much information on there so it's very clear what your table is a table of. You can even put a title for the whole graph. And I'm not coming up with these. I'm just taking it from the prompt over here. Well, what is this whole graph of? What are these tables of? They're LA County Fair pricing options. And you can just write that in there. County Fair. Price options. That's it. And this is all before I've done any numbers. I'm just labeling everything so I know what it is. So at the end, it's very clear. Just like you would with any presentation, if you had a graph or a table, you want to just put the numbers and the lines or the dots. You would label everything so anybody not knowing, that didn't do all the work would understand what this graph of. Got to have all that on there. Okay, then we go through and actually figure out. Okay, so option 1, if I don't, and it's a good idea to always start at 0 here, because that's your y-intercept when you're graphing. The y-intercept of being your equation. You have to find the equation of the line. So start at 0. I noticed on the final some people started at 1. So I know it's talking about number of rides, so you think, well, yeah, well, how much for one ride, 2 rides? But really want to start off with, well, what if we didn't go on any rides at all? Option 1, how much would that cost? We didn't go on any rides. 0. Right? It says it's $15 just to get in, so that's $15. Even if I didn't go on any rides. And since each ride is $3, 3 more than 15, if I went on one ride, it costs me $15 to get in, and then $3 for the one ride. And then you can see the pattern formula. 2 rides would be $3 more. And so on. And this is something you can figure out. Just imagine you went to the fair. Yeah, you go to the gate, you pay $15. Every ride you went to, you had to give them $3 more. And you can figure out these numbers. Or they also have it's like a wristband. If you have this wristband, you get in. It's $30. You get in. Right, so you haven't gotten any rides. You just get in. It's $30. So then once you go on your first ride, how much does it cost? $30. That's a better deal. if you go on 2 rides, it's $30 and so on. So this does require some vocabulary, understanding what unlimited means. It does help if you've been to the fair before, because you've probably seen these two options. You kind of know how it works, like you've seen it displayed on the boards. But if not, be very careful before you just jump to conclusions, like thinking like, well, that means it's $30. This is going to go up $30 every single time. So that means 2 rides would cost $60. 3 rides would cost $90. And you should look over here and say, well, wait a minute. 2 rides here cost $21. Paying $60, that wouldn't make sense. So there's something wrong. So go back to the doesn't make sense factor, and it really gives you an idea of if you're on the right track. If you're just trying to take a number and then double it and triple it and just kind of come up with an answer for the sake of it, it's probably not going to be good. Alright, so let's go ahead and graph these two. Now, one thing we did struggle with also on the task there is the scale. One thing that's very important is that down here in the corner, it starts at 0 for both, the y and the x. This way and this way, it starts at 0. And each square you have to count by the same amount. You can't, like, so since this starts at 15, you can't just go 0, 15, right, 0, 15, and then go 18, because then this square would be 15, and this square would be 3. And if you're trying to find the slope and rise over run, well, if you go up 2, is that up 15? Is that up 30? How much is it? If you're counting these by different amounts, you can't find a rise over run, you can't find a slope. So it's very important to always count the same amount. So you have to go back over here and look at, well, what's your smallest number? What's your biggest number you're trying to graph? See how many squares you have to graph with, and figure out how much to count by. Okay. It might be easier actually to start with the x here. So we're only going up to like 6 or maybe 7 or 8. But we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 16 squares. So that's a hint that we should probably count every other square be the next day. Because our goal is to use as much of the graph as possible. That's always the goal. A bigger graph, a neater graph is always preferred. So we're counting by half days, really. It's like a half, 1 day, day and a half, 2 days. I mean, that's tickets, right? So use as much of the graph as possible. So we want to start counting here, and we want to go as high as possible. That makes sense. If we counted and we stopped right here, that would not be good because that would only use a very small portion of the graph. So probably need to count by, I don't know, these are all multiples of 3, so it kind of makes sense to count by 3, right? So start by counting by 3. 0, 3, 6, and so on. And we have to put these in here. We can't just start at 15 and then go to 18. Right? We have to, each one has to be 3 exactly. That's a must. And this is the same in any science graph or any graph or any class. That's always the case. You can't skip. 36, 39, 46. Okay. Now we can. So we got 0, no rides, cost $15. I got running rides, cost me $15. Y-intercept. 1 ride costs 18. 1 ride costs $18. Okay. 2 rides is $21. Alright, and then from there, just like you figured out the pattern here, it goes up 3, goes up 3, goes up 3. There's a pattern here as well. You can just continue that pattern. And so. And the unlimited option, the option 2. Oh, by the way, we should probably, since we have two graphs on here, we're going to call this number 1. Another possibility, if you're doing this by hand for presentation or if you do it on computer, do like what I'm doing. I'm color coding it. That's another way. That way you wouldn't have to label it very clear. The blue one is the blue graph. So I can do this one in red. It'll be the red one. So 0, 30, and of course price stays constant. So the equation stays constant. No matter what, it's always $30, no matter how many dollars. Now, two things to mention. Should I draw a line through this? Okay, so going back to, is this a discrete function or is this continuous? And is it possible, when you say discrete, you're looking at the x variable and asking yourself, is it possible to do a fraction of one of these? Okay. Is it possible to go on 2.5 rides or 4.75 rides? No. Right? You can't go on fraction of rides at a fair. You're on the ride and you finish the ride. You went on a ride. That's it. Right? So this is a discrete function, which means you don't want to connect it. You want to leave it just like this. It's discrete. Okay, there are other functions that we did, like with buying candy, and you could buy 2.5 pounds or 3.75 pounds. That would be continuous. So when you're thinking about is it discrete or continuous, right, think about if it's possible to do a fraction of one of these or not. So we want to leave it like this and do not draw a line through it. And if we wanted to talk about what the range was, we would have to list the actual number. 15, 18, 21, just like we saw in number 11. The discrete functions, it's not going to be from 0 to some number. Okay. Now, the whole purpose of the next 2 weeks is really finding this point right here. This is called the break-even point. It's where the two graphs meet. And it's important because at some point, one of these options becomes more expensive or cheaper than the others. And there are people that are called financial analysts that do this for a living for companies. When they need to buy things, they have all these different places they can buy it, and they compare them all, and they find out, well, we're a small company, we're only going to need a few, so this option is better for us. Or we're a big company, so maybe in the long run, this option, option 2 is better for us. But they don't just have 2 options, they usually have 5, 6, 7 options with way more complicated details. But it's a mathematical process of finding out, which one is cheaper. How are you going to save, buy whatever you need to buy for this company that you work for and spend the least amount of money. Right? If you can do that correctly, it's a full career. So finding that break-even point is a really big deal, because that's the point where one option becomes more expensive or less expensive than another. And for most of your problems coming up for the next 2 weeks, this is your answer. Okay? So when you're finding this right here, you're going to find an x and a y and say, well, these intersect at 5, 30. You're going to get a coordinate for most of your answers, right? And it's going to mean something. Like 5 rides at $30, that's where they're worth the same. And after that, they're worth different amounts. So that's what this is. Where they're equal, right here, that's called the break-even point. That's where they're equal. And that's your answer for most of your questions for your homeworks for the rest of the week. Where do these two graphs intersect? So in this case, where the options be equal, not after actually, 5 rides at a cost of $30. 5 rides at a cost of $30. That's when they're equal. Notice how I put both the x and the y number in here. So if I'm about equal, we want both of them. We want the coordinate. Now, when is option 1 better? And better, they mean cheaper. Okay, so better means cheaper here. So when would you want to go with option 1? In what circumstance? Looking at your graph or looking at your tables, when is option 1 a better buy? Any ideas? Yeah? Any ideas?
If I was to go, use below 5x.
Yeah. So if you're only going to go less than 5 rides at the fair, yeah. If you go no rides at all, if you just want to go to the fair and not go on any rides, you wouldn't want to buy this because that's $30.15. It wouldn't make sense to buy this one. If you're going to go on one ride, well, that's only $18. You don't want to pay $30 if you're only going on one ride. So all of these, you can see, are better buys. Where you're going 0, 1, 2, 3, 4 rides. Since the blue is below the red, that means it's cheaper. The lower the dot is, the cheaper it is, the closer to 0. So being down here is good. It's cheaper. But then once you get up to here, you can see now the red is lower. The red is cheaper. So anything after 5 rides, it's cheaper to go with this option. So that's the whole idea. Now, is there one that's better than another? Not really. It depends on your circumstance. So it's not like we're looking for the right one to pick. You have to look at the circumstance and think critically about it and say, well, if I'm only going on, option 1 would only be good if I'm going on, let's see, for 0, 1, 2, 3, or 4 rides. Option 1 is better. Let's say you go to the fair, you've been to the LA Fair, there's a lot of things to walk around and do and see that are not rides. There are rides there, but there's other things to do. And if you like doing that stuff more, then maybe this is a better option. But if you see the fair and you just see all the rides and you don't care about the rest of it, you'll probably go on more rides. So option 2 is better for more than 5 rides. And this is, we're gonna do a bunch of these types of problems. There's more in the back. But this is a real thing that you'll do often. When you guys eventually move out, you're gonna have to get moving vans or moving trucks for all your stuff probably. And there's 5 different companies and they charge different amounts. Some charge $10 for the van, but then they say 50 cents per mile. Another might say $30 for the van, but then only 10 cents a mile. And you're like, well, which one's better? Well, if you're only going 2 miles away, this one's better. If you're going 50 miles away, this other one's better. And you actually can figure out which one's a better buy. For moving the stuff, it can cost very different amounts. You can pay $50 or you can pay $150 if you don't actually look at all the companies, call them up and ask them, hey, how much do you charge per mile? How much is it for the rental of the truck? And, if you're going to pay for it, you might as well pay the least amount possible. So it's a process you always do, or if you're trying to rent an apartment, same thing. There's all these other costs involved, and you can analyze all this beforehand. You're probably not going to sit down and make a table and make a graph, but it's the critical thinking involved that's what's important, is the fact that you know there's 2 different options, and that in one case, one option might be good, in another case, another option might be good. It just depends on the circumstances. Usually there's not just one that's always good and that one's always bad, okay? Because they're all competing with each other for your business. Okay, so we saw a few things. Remember to label everything first. Good option to do, good thing to do. Remember to make your scale accurate. You have to count each of these. Has to be the same amount. You can't just count by 15 and then start counting by 3s. And use as much of the graph as possible. And this place where they intersect is called the break-even point, or the solution, or the answer. And that's what you're going to be finding for most of your homework for the whole week is, where do these 2 things intersect? Okay. All right, so you guys go ahead on the back. Try a few more, work together, see how you do, and we'll go over it in a little bit if we need to. Okay, I'm going to go through this at a little bit faster rate. we saw here that this is going to be, for no classes, it'll be 120. And since it's unlimited, kind of like the unlimited rides on the last problem, no matter how many times we take a class, it's always costs 120. So the slope is 0, right? Our rise is 0. We're not going up any between. But then over here, option 2, it's 100, but then for $10 per class, so that's 110. If I take 2 classes, it's 120, and you can kind of see, well, there's the break-even point. When you have the same point on both tables, there are 2 classes at 120, but then this option becomes more expensive after 2 classes. So if you're going twice a month, it doesn't matter which one you go. If you're going more than twice a month, it probably makes sense to go with the unlimited. Now my question here is, what scale did you use on the y-axis? Are you allowed just to say 0, 100? No. Right? So we have, if you go 0, 100, you have to go 100, 200, 300, 400. And if you don't, so probably a good idea to count by 10. Right? Count by 10 when you do it, okay? I'll let you finish it up. And put in the title, the units, and everything. Let's finish that up. I'll pass out your homework in a moment.